the sine function. We're going to complete the table below for values of sine x. Now, remember here that we can use the cast diagram, and we know some standard angles. So for example, we know sine of 30 degrees is half. The sine of 45 degrees is 1 divided by root 2. And the sine of 60 degrees is root 3 over 2. Sine of 0 we should know is 0. So then we have a half. We have the 1 over root 2. Root 3 over 2. And the sine of 90 is 1. Now when we go to sine of 120, so 120 here, the associated acute angle is 60. So it has the same value as the sine of 60. So that gives us root 3 over 2. And by the same argument, this one is 1 over root 2. This one is a half. And the sine of 180 is 0. Now when we get to 210, which is around here, the associated acute is 30. But we're in the t quadrant. So it's going to have a half, but it's going to be negative a half because of the quadrant it's in. And then this one is negative 1 over root 2. This one here is negative root 3 over 2. And then this one is negative 1. When we get around to 300, the associated acute is 60 degrees. And we're in the C quadrant, so it's negative root 3 over 2, negative 1 over root 2, negative a half, and 360 is obviously the same as 0, so we're back to 0. We want to draw the graph of y equals sine x for values of x from 0 to 360. I've just put approximations over here that 1 over root 2 is about 0.71, root 3 over 2 is about 0.87. So from our table, we know the sine of 0 was 0, sine of 30 was 0.5, sine of 45 is 0.71, so that's going to be about there, sine of 60 0.87, so say there, and the sine of 90 is 1, and then for 120 it was 0.87, 135 was 0.71, 150 is a half, 180 is 0, and then 210 was negative a half, and we had 225 was 0.71, negative 0.71, 240 would be 0.87, 270 is negative 1, and then 300 would be here, 315 about here, 330 here, and 360 here. And then we'll join those up as best we can to give us our sine wave. And that's one complete period. The graph continues over here and over here, and it goes on to infinity in both directions. So the period is 360 degrees, and we'll be working in radians more often than not. So that's pi by, not pi by 2, 2 pi. So 2 pi radians. So here is the graph of y equals sine x drawn for 0 to 2 pi, although we can see the continuation of it here, and the arrow indicates that the trend just continues. So we're marked off in radians now, and we can see the period is 2 pi. This is one complete one. Well, what we're going to do here is compare it with the cast diagram. So if we do the angles here, 0, pi by 2, pi, 3 pi by 2, and back to 2 pi. So between 0 and pi by 2, we know that this was the A quadrant, so the sine should be positive. And between 0 and pi by 2 on the graph here, we can see that the curve is above the x-axis and therefore is positive. This is the S quadrant where the sine is positive, and on the graph between pi by 2 and pi, we can see once again the curve is above the x-axis, making y positive. When we come into the T quadrant, the sine should be negative, and indeed between pi and 3 pi by 2 we can see the curve is below the x-axis, and the same in the C quadrant, the sine should be negative, and between 3 pi by 2 and 2 pi the curve is below the x-axis. There is an app for you to play with that compares the unit circle and the graph of the sine function so that you can see better how all of this works.